So we saw in the last lecture, when we were talking about rational numbers, defining rational numbers, that there's a little bit of an issue. It's possible to represent a single quantity in more than one way using fractions. For example, here I have 1/2 and 2/4. They both represent the same part of the circle, even though the numbers are different. And that was kind of a new thing, right? This didn't happen with integers and natural numbers, where there's only one way to represent a given quantity. So this is the kind of thing it bugs us a little bit, right? We like to have one standard way, what we call a canonical way, to represent any given quantity. And the way we do that with fractions is we say that fractions always have to be reduced. Okay, so what do we mean by that? Well, what we mean is the top and the bottom, the numerator and the denominator, they can't have any common factors. You get that with 1/2, right? 1 and 2 have no common factors other than 1, which all numbers have, so we kind of don't count that one. 2 and 4, they do have a common factor. 2 goes into both 2 and 4, which is why that is not reduced where 1/2 is. Okay, so if I give you a fraction, how can you get it into that reduced form? Well, I've got an example here, and I'm going to look at this in a bit more detail than I know you would normally do this. All right, but I'm doing it for a reason. I really want you to see the reasoning behind how we get to the final answer. All right, it's the kind of thing that it's good to know why, especially as you get further along, you do some other kinds of math. There are going to be times when it is helpful to be able to break it down a little bit. So what I'm going to do is I'm going to look at these numbers, 10 and 12, and I'm going to say, look, they both have a common factor. Right? 2 divides both of them evenly. So I'm going to rewrite them that way. I'm going to write the 10 as 5 times 2 and the 12 as 6 times 2. Now I can split this up. I can make this 5 over 6 times 2 over 2, and here comes the real key step. 2 divided by 2 is 1. 5/6 times 1 is just 5/6, and there's the reduced version. Okay, and like I said, in practice, nobody writes it out in this level of detail. All right, what we do is, let's take a look at this example here. Right, we just look at it and say, look, 2 goes into 42 and 18, so do that. Divide 42 by 2, divide 18 by 2, and we get 21/9. Right, now, anytime you think you're done with a fraction, double check yourself. Look at this. Okay, can I go further? And in this case, we can. 3 goes into both 21 and 9. Right, so let's do this again. Let's divide top and bottom by 3. And now we're going to get our final result. 21 divided by 3 is 7. 9 divided by 3 is 3. 7 and 3 have no common factors. So we're done. Okay, now some of you may be looking at this and saying, well, now wait a minute. Why not just divide by 6? And if you see that, that's absolutely awesome. You definitely can do that. And it's going to save you a step. Right? If I just do 42 divided by 6 and 18 divided by 6, you get right to 7/3 and you're finished. Right? So if you see the bigger number, great. Go ahead and do it that way. You'll get to the answer quicker. If you don't, you can be methodical, start small, work your way up. You're going to get to the right place either way. Okay, I got one more example for us to look at because this one has kind of an interesting result. 49/7, or 49 divided by 7. Some of you may already be seeing where this is going, right? Well, 7 goes into 49 and 7, so let's do that. 49 divided by 7 over 7 divided by 7. That gives me 7 over 1. Now, this is a case where I would keep going. Right? 7 divided by 1 is just 7. Right? So I would take that last step, take it all the way down to an integer, leave that for my final answer. Okay, so that's reducing fractions. In the next lecture, we're going to start a several-part series talking about doing arithmetic with fractions, addition, subtraction, multiplication, and division. Now, some of you may have cringed a little bit to hear that. Adding and subtracting in particular has a bit of a reputation with fractions. But look, it's not that bad, all right? It really isn't. I promise you. Watch how I do this, and I think you're going to see that it's a little easier than maybe what you learned way back in elementary school.